Hello everyone, my name is Jeffrey Lee and welcome to the 18th episode where I talk about my book Fur Trade in Human Civilizations. Today we're going to start our discussion with chapter 5, which is more focused on developments in modern times and how it connects to that of the fur trade. So first we'll start with an introductory section, 5.1, where we talk about the pursuit of gold today and what they are and what the furs of today are. So American psychologist Edward Lee Thorndike conducted experiments with cats, observing and analyzing their behavior in a given environment known as the puzzle box, which led to the development of the psychological theory of connectionism. Thorndike postulated that learning occurs through a stimulus-response connection loop and proposed the laws of effect, exercise, and readiness. Established rewards that garner public consensus, such as wealth, fame, and status, and distributing these scarce rewards with a degree of uncertainty through various risks, challenges, and changes can effectively mobilize generations of human exploration. Previous chapters have used fur as a central theme to describe human geographic discoveries and civilizational progress. While continually improving the utilization of Earth's resources, humanity has consistently sought and created commodities that stimulate massive market demand, motivate human endeavor, and reward effort with wealth. In the short term, commodities such as fur, silk, cotton, sandalwood, porcelain, sugar, tea, and coffee have served as tangible targets, guiding the efforts of exploring individuals and groups. Just as the early age of exploration was driven by the desire for spices and silk, a specific profitable object can effectively embody the pursuit goal. Concretize the profit feedback process, inspire innovative thinking, and motivate the efforts of ambitious individuals. Different stages of human civilization have different consumption needs. Fur, as a highly sought-after commodity for centuries, has fully demonstrated its role in driving the progress of human civilization. New stages of civilization will generate new consumption demands, and new consumer enthusiasm will enter human life through the opening of new frontiers. Human civilization has developed over thousands of years, and its productivity has increased. People in different regions have traded their surplus goods of exchange of value, promote understanding and interaction among different areas, and forming early regional transportation networks. As time passed, human cognitive abilities and productivity continued to grow, gradually expanding activity ranges. Leveraging favorable natural conditions such as water currents, wind directions, and ice shelves, humans explored unknown territories to obtain more resources and accumulate wealth. The previous chapters highlighted representative trade goods and emphasized the vast frontiers opened, the immense challenge faced, and the organizational structures developed, and the levels of civilization elevated during the pursuit of these goods and profits. These complex and arduous endeavors have driven humanity from obscurity to higher levels of civilization, and gradual development over thousands of years, especially the relentless efforts following the age of exploration, have interconnected regional civilizations, mapping nearly the entire Earth's surface. Unyielding people now strive towards the more challenging frontiers of the Arctic and Antarctic. So first, let's talk about the exploration of the Earth's surface and frontiers there. We'll begin by talking about the Arctic. The Earth's surface contains many uninhabitable and unexplored areas, and historically, vast regions with little human presence were poorly understood. As a result, people wanted to explore different areas like the Arctic and Antarctic, and they were able to thanks to newer innovations. So first, about the Arctic. Following the age of exploration, generations of tireless efforts have led to extensive exploration and development of most of the Earth's surface. However, the polar regions remain largely unexplored due to harsh climates, ice and snow coverage, and scarce resources. The distribution of land and population between the northern and southern hemispheres is uneven. While the northern hemisphere accounts for approximately 68% of the world's land area and 90% of its population, human exploration of the Arctic regions, both land and sea, began earlier than that of the Antarctic. As previously discussed, the opening of the northeast and northwest passages, as well as the exploration of Siberia, Chukotka, Alaska by Russia, and Canada by Britain and France, were driven by the pursuit of trade routes and the fur trade. The Arctic is centered around the Arctic Ocean, and unlike the Antarctic, which is centered around the Antarctic continent, due to Earth's rotations, wind patterns, thermohaline circulation, and ocean currents, the northern hemisphere experiences the North Atlantic drift. This current carries warm water from the Caribbean along the east coast of North America to western and northern Europe, raising temperatures in coastal regions of the Atlantic, such as UK, Ireland, Norway, Sweden, and Iceland, above those of inland areas at similar latitudes and significantly warmer than those in the Antarctic. In contrast, the Antarctic is surrounded by cold currents that slow the melting of the ice cap, and the Arctic experiences winter temperatures ranging from -40 to -20 degrees Celsius, with summer temperatures rising above 0 degrees Celsius. In the Antarctic interior, winter temperatures often drop below -60 degrees Celsius, with summer temperatures typically ranging from -20 to -10 degrees Celsius. The warm currents allow humans to sail around the northern tip of Norway at 71 degrees north before the 15th century. In 1587, John Davis sailed through the Davis Strait between Greenland and Baffin Island, reaching 72 degrees north. In June of 1596, Willem Barents led a Dutch expedition reaching 79 degrees north, and in 1612, British explorer Thomas Marmaduke reached 79 and 48 minutes north. By 1622, British whalers had reached the northern tip of Nordøstland in the Svalbard archipelago at 80 degrees and 30 minutes north. In 1707, Cornelis Gals, leading a Dutch whaling ship, passed 81 degrees north when navigating around Svalbard. In 1882, Adolphus Greely's expedition reached 80 degrees and 24 minutes north. Efforts to approach the North Pole continued, and in 1895, Norwegians Fridtjof Nansen and Frederick Hjalmar Johansen reached 86 degrees and 14 minutes north. In 1909, Robert Peary claimed to have reached North Pole, though this is disputed, but he did at least reach 87 degrees and 45 minutes north, setting a record for the northernmost point reached at the time. In 1931, Sir Hubert Wilkins and Lincoln Ellsworth led an expedition using a rented American Navy submarine to reach the North Pole underwater. However, the submarine encountered power supply and propulsion system issues in a polar environment, and the thickness and irregular shape of the Arctic ice also made navigation and surfacing difficult. Additionally, the polar magnetic fields disrupted communication systems, and traditional navigational tools were inaccurate. Ultimately, the expedition had to turn back at 82 degrees north, and it wasn't until 1948 that Soviet explorer Alexander Kuznetsov, flying a specially adapted aircraft for polar conditions, reached the North Pole, becoming the first person to set foot there. The first overland journey to North Pole was completed in April 1968 by Ralph Placet and 3 companions who traveled along the ice on snowmobiles. In April 1969, British explorer Sir Wally Herbert became the first person to reach North Pole from Alaska by sled, a journey that took a year and involved numerous airdrops of supplies. Submarine exploration also succeeded in 1958 when a U.S. submarine reached the North Pole underwater on August 3rd. In March 1959, another U.S. nuclear-powered submarine reached the North Pole and surfaced for the first time. Despite these achievements, the Arctic Circle at 66 degrees 34 minutes north includes lands that belong to 8 countries, predominantly consisting of permafrost, where no woody plants grow. Unlike the uninhabited Antarctic, the Arctic has been inhabited for over 10,000 years, and the Arctic's resources have also been partially exploited, including centuries of fur hunting, oil and gas extraction in Alaska, and the opening of Arctic shipping routes, gradually increasing our understanding and development of the region. Recent scientific data from 1997 to 2007 suggests that the Arctic sea ice may completely melt by summer of 2040. This would allow northern shipping routes to pass near the North Pole, optimizing east-west routes into more efficient north-south routes, thereby shortening distances and significantly reducing transportation costs. Additionally, vast rivers in Siberia flow northward into the Arctic Ocean. With reduced ice cover, these rivers could provide low-cost water transport routes for inland regions like Central Asia, Mongolia, Siberia, and China, facilitating access to North America and Western Europe. The Arctic is estimated to hold about 10% of the world's oil reserves and 30% of its natural gas reserves, earning it the name the Second Middle East. The Arctic is significantly impacted by global warming, with shrinking ice caps likely to attract nations eager to exploit its oil, gas, and fishing resources, dramatically expanding current Arctic development efforts. Now let's talk about Antarctica, all the way to the south. During the age of exploration, explorers navigated around the Cape of Good Hope and Cape Horn, proving that any southern continent would be independent and not connected to any other continents by land. The first recorded human navigation within the Antarctic Circle at around 66 degrees and 34 minutes south was by British explorer James Cook's crew in 1773. Entering the 19th century, vessels ventured into southern waters for activities such as whaling and sealing. In January 1819, British Captain William Smith's sealing expedition accidentally discovered the South Shetland Islands at 62 degrees south. These islands near the Antarctic Peninsula provided a crucial stepping stone for the further southern exploration. The following summer, in January 1821, Russian explorers discovered Peter the First Island, about 450 kilometers west of the Antarctic Peninsula at 68 degrees south, marking the first recorded human sighting of land within the Antarctic. Scott's expedition reused Ross' discovery of the Ross Sea and attempted to land at the McMurdo Sound for further exploration. McMurdo Sound, with a similar longitude to New Zealand, allowed deeper southern penetration via the coastal route. In the same expedition, a smaller team successfully reached the South Magnetic Pole on January 16, 1909, and climbed Mount Erebus. Norwegian explorer Roald Amundsen, well prepared with equipment, supplies, and personnel, reached the South Pole on December 14, 1911, achieving the first human arrival at the pole. In January of 1956, the United States established the Amundsen-Scott South Pole Station, named in honor of both Amundsen and Scott, recognizing their significant contributions to Antarctic exploration. After the initial success of reaching the South Pole, the next significant challenge was to traverse the Antarctic continent. Ernest Shackleton planned to start from Vahsel Bay near the South Atlantic, cross the Antarctic continent, and reach McMurdo Sound in the Pacific, establishing a route connecting the Atlantic and Pacific Oceans. Shackleton's expedition aboard the Endurance departed from South Georgia but became trapped in the ice of the Weddell Sea in early 1915. After 10 months, the Endurance was crushed and sank. The first successful trans-Antarctic crossing was achieved by Commonwealth Transatlantic Expedition from 1955 to 1958, led by British explorer Vivian Fuchs. In the 1955 and 1956 austral summer, Fuchs and a reconnaissance team established a base at Vahsel Bay and left 8 men there. The ship was trapped in ice but eventually freed with help at an aircraft, and in the 1956-1957 summer, Fuchs consolidated base and began an overland journey on November 24, 1957. The first aerial crossing of the South Pole was achieved on November 29, 1929, by American explorer Richard E. Bride. Byrd and his 3-man crew flew from their base on Ross Island to South Pole, dropped the marker, and returned to their base, completing the 16-hour flight. Byrd's achievement paved the way for future coordinated land and air explorations, significantly supporting the subsequent Antarctic expeditions and research. The first aerial crossing of the Antarctic continent was accomplished in 1935 by American millionaire Lincoln Ellsworth. On December 5, 1935, Ellsworth's plane took off from a base on Ross Island, flying for 14 hours and covering 3,700 kilometers before landing at Sledging Bay in the Weddell Sea. One of the largest Antarctic expeditions was the United States Navy Antarctic Development Program, conducted from 1946 to 1947. This operation involved 13 ships, including an aircraft carrier, 33 airplanes, and 4,700 personnel. Arriving in the Ross Sea area in late December of 1946, the team established a base on the Ross Ice Shelf. They conducted flights over 220,000 square miles, researching meteorology, geology, glaciology, and biology, while training personnel and equipment for polar conditions. Human exploration of Antarctica has continued to this day, with various countries establishing scientific research stations for joint studies. Besides its severe cold and dryness, Antarctica is also known as the polar winds due to its extremely strong winds and high wind speeds. Antarctica is a white, isolated continent at the Earth's southernmost point, starkly contrasting the green environments where humans typically live. However, the exploration of Antarctica is of immense importance to human civilization. First, Antarctica is crucial for understanding the Earth's dynamics, cosmic activities, and human impact. It significantly influences global climate and ocean systems and contains valuable records frozen within its over 4-kilometer thick ice sheets, serving as a reference for studying global climate. It has vast reserves of coal, iron, oil, natural gas, copper, lead, and zinc, as well as abundant marine biological resources. For instance, the current estimated biomass of Antarctic krill is about 6 to 12 billion tons. Conservative estimates suggest that harvesting 50 million tons annually would not disrupt ecological balance, equating to 50% of the world's current total fish catch. Moreover, Antarctica has abundant freshwater resources. Although its harsh environment is unsuitable for human habitation, its unique landscape holds potential for tourism development. Now let's talk about exploring beneath the surface of the Earth. The renowned French science fiction writer Jules Verne once penned a novel, A Journey to the Center of the Earth. The book narrates the story of a German geologist who accidentally discovers an entrance to the Earth's core through a volcanic crater in Iceland. Overcoming numerous challenges, he and his companions reach an underground sea surrounded by gigantic plants. Eventually, they are swept into a deeper subterranean region by seawater, triggering a volcanic eruption that expels them to the surface from a volcano in southern Italy. While the story is captivating, humanity's 5,000-year-old civilization still faces numerous unknowns beneath the Earth's surface. Direct human entry into the Earth's interior currently faces significant objective challenges. Therefore, research on the subsurface is mainly conducted through methods such as seismic waves, drilling, and geomagnetic field analysis. Seismic wave analysis is akin to CT scan in medicine. Scientists use seismic wave data to create three-dimensional regions of the Earth's interior, and Earth generate both transverse waves, S waves, and longitudinal waves, Q waves, which change speed when passing through different materials inside the Earth. By establishing a network of seismic monitoring stations at various locations worldwide, scientists can continuously collect seismic wave signals. Similar to medical CT scans, scientists analyze the data collected from these stations to create three-dimensional images of the Earth's interior. Geomagnetic field analysis is based on the fact that the Earth's core is composed of iron and nickel, and the movement of its liquid components that alter the geomagnetic field. By continuously measuring changes in the geomagnetic field, scientists can infer the movements within the core. So first, let's talk about oil drilling, one way that humans have tried exploring the center of the Earth. The United States was the first country in the world to begin oil drilling. In April 1968, the Challenger deep-sea drilling ship entered the Gulf of Mexico, initiating the Deep Sea Drilling Program, or DSDP. Over the next 15 years, 96 drilling expeditions were conducted, covering a total voyage distance of 600,000 kilometers. The DSDP drilled 1,092 deep-sea boreholes at 624 locations, collecting over 97 kilometers of core samples. This extensive data collection covered all major oceans except the Arctic Ocean and provided substantial evidence supporting the theory of seafloor spreading in the South Atlantic and the theory of plate tectonics. Starting in 1985, the New Generation Ocean Drilling Program, or ODP, was carried out over 18 years with international cooperation. The ODP conducted 111 voyages, covering a distance of over 35,000 kilometers, and drilled nearly 3,000 boreholes across the world's oceans, amassing a total of 215 kilometers of core samples. The ODP explored the structure of the seafloor crust, the formation of underwater plateaus, the periodicity of climate evolution, and significant events in Earth's environmental history. In October of 2003, the ODP concluded, and the larger and more ambitious Integrated Ocean Drilling Program, or IODP, was launched, led by the United States and Japan. From 2013, the new International Ocean Discovery Program was successfully conducted with the participation of 24 countries. The program focused on analyzing Earth's history, current state, and future through drilling and experiments under four main themes: climate and ocean change, biosphere frontiers, and Earth's dynamic systems and Earth in motion. Now let's talk about continental drilling. In 1835, the Zhejiang region of China used percussion drilling methods to create the world's first well, exceeding 1,000 meters in depth. By 1930, Europe had drilled wells reaching depths of 3,000 meters, and continental scientific drilling began later than ocean drilling. In 1977, Germany proposed the Continental Deep Drilling Program. After 10 years of assessment, validation, and site selection, Germany completed the main borehole from 1987 to 1994, and scientists from 12 countries conducted over 200 studies. The German Continental Deep Drilling Program was initially intended for scientific research periods, significantly expanding human understanding of the Earth's interior. In 1996, Germany, the United States, and China initiated the International Continental Scientific Drilling Program, or ICDP. Scientific drilling has overcome numerous unprecedented challenges. High temperatures, high pressures, and high stress conditions in deep rock layers can cause damage to equipment that operates under extreme conditions for long periods. Since the 1960s, hundreds of scientific boreholes have been drilled around the world, both on the ocean floor and on land. These boreholes are characterized by depth into 4 levels: shallow, medium depth, deep, and ultra deep. Through these direct investigations, humanity has studied the internal structure and evolution of the Earth's geology, the role of deep-sea fluids, and has validated geophysical survey results. Despite drilling down to depths of 12 kilometers, humanity has yet to reach the manticore boundary, leaving vast unknowns below the Earth's crust for future exploration. Understanding the subcrustal environment not only helps us comprehend Earth better, but also aids in analyzing the interiors of similar celestial bodies. This research provides clear insights into Earth's formation, evolution, and future trajectory predictions, contributing significantly to the exploration of the universe and the advancement of human civilization. That's it for today's episode. As always, if you want to purchase this book, the link to the Amazon is in the description. And if you enjoy this series, feel free to like and subscribe. Thanks for watching.